Okay, so you guys are looking at this question next, and you have the option to click the link and run through the simulation yourself. But for those of us who are maybe working on an iPad or something that won't run the simulation, you are more than welcome to follow along in this video. So I will be walking you through all of these answers. I'm not going to show you which answers you're going to be dragging up there. I do expect you guys to be able to handle that yourself, but I will show you what you need to see on the simulation itself. So I'm going to move that out of the way. So first thing that we're looking for is the chemical formulas. So I'm going to click on micro right here. And what we end up seeing is that we have sugar or sucrose, okay? And then you have these funny letters with their subscripts right here. That is the chemical formula. And then you have sodium chloride, NaCl, up here. And that is your chemical formula. So go ahead and fill in those couple things that you have. And actually, just to keep clicking over, we also have sodium chloride, calcium chloride. So I'll let you see those for a second. And now for the last ones, we have sodium chloride, sodium nitrate, which is not on our data table, but we do have this. We do have glucose. So you might need that chemical formula. Okay, so now what we're going to do is you're going to take a second and you're going to look at each of those formulas again, and you're going to decide if there is a metal present. So I'm just going to show the periodic table is right here. And remember, everything to the left is considered a metal except for hydrogen. Everything to the right is a non-metal. So looking at our couple chemical formulas, you need to decide yes or no if there is a metal involved. So take a look at glucose. Is there a metal involved? Looking at sucrose. Is there a metal involved in sucrose? So again, you see the ones that are getting highlighted. Then we're going to check on our sodium chloride and calcium chloride. So I'll leave that for a second. So you can see our sodium, chlorine, and then calcium chlorine. We're also going to check, keep getting rid of our periodic table. There it is. Calcium over here, chlorine over here. So please label those as yes or no in your data table. You can pause the video and do that yourself. Moving on, the next part, we're going to be deciding, is it ionic or is it covalent? So remember, if there is a metal involved, if you had anything in this gray region on the periodic table, then it is going to be considered an ionic compound. Go ahead and label the 4 substances as being ionic or covalent. Just so we know where we're at, we're in this column right now. So you want to be looking here. Remember, if there is a metal involved, if you have yes on any of these, that one is going to be ionic. Okay. The next question we're going to be answering is, does it dissociate? Do the atoms separate in water? So we're going to change our simulation over to, actually, we're going to leave it in micro for now, and then we'll go over to water in a second. But let's go ahead and look at our original first two, which is the sodium chloride and sucrose. So here's some sodium chloride. So if we sprinkle that in, you can kind of see those things are falling down slowly because we're recording. Okay, and as you see them drop into the water, you see that those different atoms are separating in the water. This would be considered dissociating. Okay, so now we're going to pull the little lever. We're going to let out the water. We're going to reset it. Now we're going to change over to sucrose. Again, we're looking for the separation of the atoms, the individual atoms, not necessarily the molecules. Okay, so as you can see, we're just going to dump some of that sugar in there. You can see that it comes in big chunks. And now we're looking to see, are the atoms separating? So it looks a little different than what we had when we had sodium chloride. So here's sodium chloride again. And you see that when you put sodium chloride in there, the green and the purple completely separate from each other. So remember, your sucrose is the red and gray ones. So you can see that those are kind of sticking together. Okay, so moving to our other two categories, we have glucose and calcium chloride. Here's calcium chloride. See how that one comes out. And you need to be labeling, are they separating or dissociating in water? So we can see that all those atoms split apart again, very similar to when we had our sodium chloride. And finally, let's look at glucose. And when that gets put in the water, we're seeing them still sticking together. They might have dissolved. So this is showing that they are dissolving, but they are definitely not dissociating into their individual atoms. So now you should have this column filled out. You should have your dissociates, do the atoms separate in the water. You should have yeses and nos, or dissociates and does not. Now we're going to answer conducts electricity, yes or no. So I'm going to go ahead and reset this. We actually have to go back over to macro, the first tab. So if you're following along on your simulation, the first tab. And what we're going to do is we're going to take our sugar, that's the first one listed in our data table. I'm going to sprinkle some of the sugar into the water. So now it looks like macro, meaning what we see with our naked eye. Okay, so I put a bunch of sugar in there. Now I'm going to take this little conductivity meter and I'm going to put it into the water. And what we want to see is if it conducts electricity, then there should be a circuit that's formed and this light bulb right here should light up. If it is not conducting electricity, it's not going to light up. So we put that in the water. As you can see, it did not light up. So we're going to put you back over here. We're going to remove the sugar. Let's put some salt in and see what happens. So when we sprinkle salt in here, okay, now we're going to take that conductivity meter again. You can see that we have evidence of it lighting up. Okay. If we reset it all, if we were to start with some sugar and we were to put that conductivity meter in there and then follow up with a little salt, we should start seeing it light up, which we just did. So salt is definitely something that conducts electricity. Sugar is not. Okay. Now, if you notice, we do not have any options to look at glucose or calcium chloride. So please put the correct answer into those two boxes. The last thing I'm going to show was on that last tab over here, and you can kind of explore it on your own if you want to pull up the simulation. But what we're going to see here is that these are all little water molecules, okay? And if we were to dump some of the sucrose in there, we would end up seeing that the molecules are sticking together. So once again, they are separating from each other, meaning that it's dissolving. That's how we're able to make some of our Kool-Aids and things like that. But they are not dissociating, meaning the atoms themselves are not splitting away from each other. They are holding on because they are bonded together. When we look at the sodium and chlorine, the sodium chloride or salt, and we put that into water, the water molecules are actually pulling these atoms apart from each other. Okay, and it has to do with something that we're going to see with the charges and polarity. But ionic substances will tear all of the atoms apart, the ionic bonds, and your covalent will not.